Good morning children. Today we are going to discuss about our new topic, it is prime and composite numbers. Okay, in the previous topic itself we have discussed what are factors. Factors means the numbers, okay, that divides the given number exactly. That means there will be no zero. So with that concept we are going to find out what are prime and composite numbers. So for a prime number, if the prime number means it will have only two factors. It will have only two factors, okay, which is 1 and the number itself. Okay, it will be 1 and the number itself. Only the two factors are that number and 1. So that only is the condition for prime number. Okay, so if the opposite of that is a composite number. So a number having more than two factors. Okay, that will become composite number. Okay. Next, a perfect number. What is this perfect number? If the sum of the factors is equal to the same number, that will call the perfect number. You should know this. Okay, it's a very important thing. Example 6. 6 is a perfect number. What are the factors of 6? How and all we can get 6? It can be 1 into 6 or 6 into 1. Then 2 into 3 or 3 into 2. Apart from that, there's no more factors. So what are the factors? You cannot repeat the number. So it is 1, 2, 3. When I add 1 plus 2 plus 3, I will be getting 6. So that is why 6 is a perfect number. Okay. Now we are going to check whether the given number is a prime number or a composite number. For this, you simply do one thing. First of all, you should write 1 to 100 in a table like this, starting from 1 to 10, 11 to 20 like this. Now leave 1. Now take 2. 2 will go only in two tables. It will not go anywhere else. So 2 is a prime number. 3 is also a prime number. 3 will go in three tables only. Now coming to 4. Where will 4 go? In which table 4 will come? It will come in two tables. So you cannot take 4 as a prime number. So it will cross it out. 5. 5 will go only in one table or it will go in 5 table only. That's all. It will not come in any other table. So you can cross that. Or you can just put the circle. So these circles are all prime numbers and all the crossed ones are all composite numbers. Like this, you should know till 1 to 100. You should memorize this. Then only it will be very easy for writing the 1 mark. Okay, say 2, 3, 5, 7. So you have 4 numbers here. 2, 3, 5, 7. All the odd numbers except 9. Then 11, 13, 17, 19. So all the next 4 odd numbers except 15. You can remember like this. Then in the third column you will have only 2. It is 23 and 29. Because the rest of all the numbers will be appearing in either of the tables. That is the logic. Okay, so you can cross out all this. Then finally you can arrive at 25 numbers between 100. From 1 to 100 you will have 25 prime numbers. Okay, only prime number that ends with 5 is 5. Okay, all these are all 1 marks. Okay, now how are we going to express a number as a sum of prime numbers? Okay, say 42. Okay, and 100. How I am going to do? 19 plus 23, 147 plus 53. Then similar example, 31 and 59. You can express 31, 5 plus 7 plus for all this, you should know this table thoroughly. So write this in your classwork notebook. After writing the topic prime and composite numbers, write these two definitions. Write the definition for perfect number. Then go to this table. Write this table, write these examples. Okay, write the examples 1, 2. Now, coming to the twin primes. Twin prime means the difference between them is 2. Difference between them is 2. Okay? Like 5, 7, 17, 19, or it can be 3, 5. Okay. Now, if it is having the 3 successive prime numbers differ by 2. 3, 5, 7. 3 numbers. So I have only one triplet. That is called the prime triplet, which is called 3, 5, 7. Okay. Now coming to the divisibility rules. Now what I am going to do in this divisibility rules means they will give one number. We have to check whether that number is divisible in either of the numbers. What are all the numbers we have to check? We have to check for 2, 3, 4, 5, 6, 7, 8, 9, 10 or 11. So for all these combinations we have to check. First rule for 2. So divisibility by 2. If I am given a number, if that number is ending with 0, 2, 4, 6 or 8, that means it is divisible by 2. So you have to write this rules. Which all I am putting a tick mark. You should write this in your classwork notebook. Okay. Then the divisibility by 3. For 3, what I am going to do is, I am going to sum the digits and see if it is divisible by 3. So I write this only. This is the rule. Write the topic, write the rule. The black, the bold one is the rule. Okay. Then give one example also. So divisibility by 5, it should end with either 0 or 5. Okay. Now coming to divisibility by 4. For 4, 2 conditions. First condition is the last 2 digits. The last 2 digits should be divisible by 4. Okay. If the 2 digits are all zeros also, then it is divisible by 4. So these 2 conditions you should write. Okay. Divisibility by 6. If it is divisible by both 2 and 3, then the number is divisible by 6. Then the rule for 7. Okay. Nothing. It will be, I have to divide directly by 7. Okay. Divide the number directly by 7. That is the rule for 7. Right? Divisibility by 7. What is the rule? Divide directly by 7. Divide. Okay. Then divisibility by 8. How I am going to divide by 8? The last 3 digits. Take the last 3 digits and see if it is divisible by 8. Then the number is divisible by 8. Then divisibility by 9. Divisibility by 9. If the sum of the digits is divisible by 9, it will be divisible by 9. Then divisibility by 10. Divisibility by 10. End with 0. No other condition. For 11, alternate numbers you have to add and find the difference. If that difference is divisible by 11, then the number is divisible by 11. So you have to write with this example. Okay. Now coming to the prime factorization, which I will take it in the next class. Okay. Till divisibility rules we have discussed. With this we are going to see the examples, or we are going to do the exercise. First is the number of prime numbers between 11 and 60. You have to go to the table, count between 11 to 60. How many prime numbers are there? How many prime numbers are there between 11 to 60? You have to count. That count is 12. They are asking only the number of prime numbers. Okay. So the numbers 29 and 31 are twin primes. 29 and 31. Then 3753 is divisible by 9. So anything which is divisible by 9 will be divisible by 3. So that is a rule. Okay. Then this prime factors I will take it later. Now coming to the true or false. Coming to the true or false. The sum of any number of odd numbers is always even. No, false. Every natural number is either prime or composite. False. Because it cannot be both. It has to be either one. Okay. And here the natural number 1 is not neither prime nor composite. So every natural number we cannot take. Okay. So if a number is divisible by 6, then it must be divisible by 3. It is true. Then if 16,254 is divisible by each of 2, 3, 6 and 9, we have to test and see. For 2, it will be ending with 4, so it is an even number, so it should be dividing by 2. Then for 3, add all this. 1 plus 6, 7, 7 plus 2, 9, 9 plus 5, 14, 14 plus 4, 18. 18 is divisible by 3. then again it will be divisible by 6, it will be divisible by, so the whole number is divisible by all these numbers. So the number of distinct prime factors, this we will see later. Okay, so I am rounding off that, so which will be saying later. Prime factors we will see in the next class. Next, the smallest and the biggest 2-digit prime number. The smallest and the biggest 2-digit, you can take it directly from the table. So the smallest is 11 and the biggest is 97. Okay, the smallest and the biggest 3-digit composite number. 3-digit composite number, smallest is 100. Biggest 3-digit composite number is 999. Okay. Now, the sum of any 3 odd natural numbers is odd. Okay. Yes. So, you can justify the statement with an example. Take any 3 odd natural numbers. 3 plus 5 plus 7. If you add, you will get an odd number. So, this statement is true. You should write the given statement is true. Okay. Justification, write justification and write 3 plus 5 plus 7. All 3 are odd numbers. Okay. When I add, you will get 15. Okay. I will write and show how I am going to write. 1 minute. You should write it like this. The statement is true. Then write justification. Consider 3 odd natural numbers. That is 3, 5, 7. Okay, sum of 3 odd numbers equal to 3 plus 5 plus 7, which is equal to 15, which is an odd number. Odd number. Therefore, the given statement is justified. So, given statement is proved. Okay. Now coming to the 6th one. The digits of the prime number 13. Okay. Can be reversed to get another prime number 31. Find if there any such pairs exist. Okay. Now I am going to check the table. So 17, if I reverse, I get 71. Then 37, I can reverse, I will get 73. 79, if I reverse, I will get 97. All this is possible only when you mug up or you memorize the table for prime numbers. Okay. Your friend says that every odd number is a prime. No, this is false. Why? 9 is an odd number. Okay. 9 is an odd number. But 9 is not a prime number. Okay. Is it not? 9 is not a prime number. Why? Because 9 appears in the table of 3. 3 3s are 9. So, prime is 9 is not a prime number. So, every odd number is not a prime number. Okay, prime number. You should write that. Now, coming to the 8th one. So, each composite number has at least 3 factors. Yes. Okay, yes. Or you should say true. Why? Take a composite number 4. Example, consider a composite number. First composite number 4. What are the factors? Factors of 4. How will you find? 1 into 4, 4. Or 4 into 1, 4. Then 2 into 2, 4. Okay. Then, so what are all the factors of 4? This also will be 2 into 2. So 1, 2, 4. 1, 2, 4. So what are all the factors? The number of factors of 4 are 3. So every composite number will have 3 factors minimum. If it is having 3 factors, then obviously it will become a composite number. Okay. Find the dates of any month in a calendar which are divisible by both 2 and 3. Both 2 and 3, you can very well go for 6 tables. Both 2 and 3 means it is divisible by 6. Or you can very well write the tables of 6. That is 6, 12, 18, 24 and 30. Except this cannot be used for February. Except February month. Okay. Now, I am a 2-digit prime number. Coming to the 10th question. I am a 2-digit prime number. Sum of my digits is 10. Okay. I am also one of the factors of 57. Who am I? Okay. So 2-digit prime number. Sum of the digits is 10. You can, if you know the tables or the tables of prime numbers between 1 to 100. If you see which digit you will add, you will get 10. 1 plus 3 will not give 10. 17 plus 1, 7 plus 1 will not. 9 plus 1 will give you 10. Apart from that, everything will go beyond 10. So 19 is the answer. Okay. This prime factorization I will do it later. Okay, in the next class. Now, coming to this portion, the difference between two successive odd numbers is 2. The only even odd prime number is even prime number is 2. Okay, which of the following numbers is not a prime? This 92 because it ends with 2. Then the sum of the factors of 27, I will tell you this later. 16th I will teach it later. Okay, if the factors of 1, 2, 4, 5, 8, 10, 16, 20 and all, what will be the number? This number is 80. Okay, these two numbers I will do it later, and 11th problem and the 12th problem I will do it in the next class. Now moving to the 4th unit where we discussed about the types of triangles. Here today we are going to discuss the types of triangles based on its angle. So what are the 3 angles we have discussed in the first term? Acute angle, obtuse angle and the right angle. Okay, so acute means which is less than 90, obtuse means more than 90, and if it is a 90 degree means it's right angle. With based on these 3 angles, we are going to have 3 triangles. If it is acute angled triangle, right angled triangle or a obtuse angled triangle. Okay, and the main thing is you should write all this with the diagram. You should draw this angle or this one, 3 angles. Okay, with that you can directly go to this, try these. One more thing is the sum of the 3 angles should be always 180 degree. The sum of the angles should be 180 degree. That particular rule is already, wait, we'll see. No. Yeah, we have already seen in the properties of the triangle. The properties of the sum of the 3 angles should be 180. So if all the 3 angles, if you add all the 3 angles, it is equal to 180 degree, then it will obviously form a triangle. Otherwise it will not a triangle. Accordingly you have to write. So for 50, 40, 90. If you add, it will become 180. And then there is one angle for 90. So this is a right angled triangle. For 60, 30, 90, again there is one 180 degree. So 90 degree means, so it is a right angled triangle. For 95, 40, 35, the total angle is 170. So no, it will not form a triangle at all. For 110, 40, 30, you will get 180 degree. And since there is 110, it will be an obtuse angled triangle. The last one, you will get a total of 280. So it is not a triangle. Then you have to write the triangle inequality property. That is, the sum of the any two sides is always greater than the third side. Sum of the any two sides will be always equal to greater than the third side. So, okay, then if three sides are equal, then we can form a triangle. Okay. If two sides are given, the third side will lie between the difference. You should write all these 3 points. Okay. Now, with this example, we are going to go with this try these. Okay. Now, the sum 7 plus 10 is 17. Okay. This 17 is greater than the third side. Okay. The sum of the two sides is greater than the third side. So, yes, that triangle can be formed. And what will be the type of the triangle? All three sides are different. So, this is a scalene. Okay. So, this will be a homework. You should do this homework and take a picture and send it to me. Okay. Now, this is 18. 10 plus 8, 18. Again, this is greater than 8. So, you can form a triangle. Two sides are equal. So, this is a isosceles triangle. If you add these two, again, this will be greater than this. These three sides are different, so this will be a scalene. Similarly, you should find it out. Now, consider this. 4 plus 5 is 9. Okay. Now 9 and 9 is less than 12. Okay. You cannot take all different ways. You should take only in the ordered way. Okay. So, if you add this, it will be less than that. So, I cannot form a triangle. Okay. It should be in the order. Then, coming to exercise 4.1, every triangle has at least two acute angles. Okay. A triangle in which none of the sides are equal is called scalene triangle. In isosceles triangle, two angles are equal. Then the sum of three angles is always equal to 180 degree. In a right angled triangle, the two sides are called as isosceles right angled triangle. Isosceles right angled triangle. How are we going to match? No sides are equal, isosceles. Sorry, no sides are equal, scalene. One right angle, it is called right angled triangle. One obtuse angled triangle. Two sides equal, that means it is isosceles. All sides equal, equilateral. Okay. For these triangle, you should write mention the sides, angles, vertices. A, B, B, C, C, A. On the top, you have to write the bar. This angle sign, you have to write for angle A, angle B, angle C. Three vertices, A, B, C. Then, you can write based on the sides given, which type of the triangle. First one is equilateral, second one is scalene, third one is isosceles, and the fourth one is scalene again. Then, depending upon the angles, you can write these all are less than 90, so this is acute. One angle is 90, so this is right angled. One angle is more than 90, so this is obtuse angle. And the last one is again acute angle. Okay. So, you have the till 5 we have completed. Okay. From 6, 7, 8 we will see it in the next video. Okay. So, till 5 we have completed. Okay. You can draw this, you can write this in the textbook itself. Okay. Thank you.